Hello, this is a short video to show you how to use the Copelia Sim simulator. You have to download the version of the simulator from this web page. This is the version that we use because it's the educational version. You have to download and install it. It's totally free. After that, you will have the simulator installed in Windows. So when you open it, you have the simulator working. So here you can do your experiments. So here you have some kind of predefined model that comes with the simulator, but in our case the Kepler 4 robot doesn't come with the simulator. So you have to add it. I will give you the model, and you have to add it here. So in your path where you install the model, you copy where you install the simulator, sorry, you copy the model, which is the TTM file, and you have to copy inside here program files, Copelia Robotics, Copelia EduSim, models, robots, mobile. And here when you paste it, you paste the model here. Now when you update the simulator, you will see that here you have the robot. This robot was this model was developed by a student of Professor Gonzalo in PUCB. So here you have the model of the robot, and now you can execute your simulation, and you see in this case the robot is doing nothing, just different velocities for both wheels. So here you can program the code to control the robot. As you can see here, you only have the velocity of the right motor is 5, and the velocity of the left motor is 3. So that's why he is making a circle. No, so this is a basic example, but also we will give you some other example that we have saved. So I copied this folder to here, to this path, program file, Copelia Robotics, Copelia Scenes, where they give you a lot of examples with different robots or different kind of experiments, and we will give you this folder. You copy there or where you prefer. So for example, this is the same model, but in this case for a position control of the robot. So the robot have to reach the destination point, which is this semisphere. So also here you see the code associated to this experiment, which is a traditional position control of the robot, no, in a traditional approach. So you also need to install Spider, which is the Python editor that we use. We use Anaconda. From this web you can download it and install it in this way. Maybe you know Anaconda, but we are doing the entire guide. So we will connect a Spider with a VREP or with Copelia simulator. So you install Anaconda, from this link, depending of your operating system. After that you can start Anaconda in this way. Of some components, and after that here you have the components of Anaconda, and you will use Spider. You can use a different software to work with Python if you want, but we are showing what we use. And this is the interface to work with Python in Spider. So we have to add some libraries. These are the libraries that we have to install to work with Python and VREP. This is an example of how to install NumPy, but you have to install all of them. We only show NumPy. For example, they are already installed. So when you install it, you will see that they will be checked with the green check mark. Once you have all these files in this folder, you have to add the simulation in VREP that you will execute and the Python file that you will execute externally in the same folder. So you start the simulation in VREP, and here you have the environment with the experiment load. So in the previous example that we show you, the controller was running on board the robot or in the script of the robot in this software. But in this case, now we show you the script of the robot in this case, which is quite different because it will run the simulation, but the controller will be running in Python externally in Spider. So here you have some handles to the motors of the robot and to the target point, and at the beginning we put the motor with velocity 0 of both motors, and here you start a TCP connection where VREP is is working as a server in this port. And now in Spider you have the controller. You need to have everything in the same folder, the Python file and the simulation. So now this is the Python file where the controller is implemented. So this is the importation of the libraries that we use, that we already installed in Anaconda. And here you close all the previous connection if you have someone, and here you have a connection, or you establish a connection between this client and the server, which is the VREP in the same port. So the port have to be the same, and in this case the VREP only will send the data to Python, and in Python the controller is implemented, or the velocities of the robot are calculated. This is the traditional position control as I showed you at the beginning, but now is running in Python distributed. So it's the same experiment as you can see. And at the end, it obtained the velocities of the motors, and it sent it to VREP to the robot, and the robot applied those velocities. So to start it, you have to start first the simulator, because this is the server in the TCP connection, TCP IP connection. So now the robot is stopped because it is only waiting for the connection. And if you start Python, the connection is established. You can see it in the console, and the robot start to move. And now the traditional position control experiment is working, but as I say, in a distributed form. As you see, the robot goes to the semisphere 2. And this is a very nice example to show how to use Python as code programmed with the experiment. This is another example with a YOLO classifier to detect the objects, traffic signals. For example, this is the TriNet classifier to detect stop and different signals, arrows, speeds, etc. So in these lines you connect to VREP. So in this part of the code you detect the signal with the classifier. So you count how many times you detect the signal, its size. For example, if the detected signal is the stop, you count how many times you detect it in the image. So depending of the quantity of the signals detected, the state of the robot change between stop or turn left or turn right or go. And this part of the code detect the track using also the image of the camera. And at the end, you send the velocities to the robot. Here you start the simulation. The robot is waiting for the connection, and now you start the Python code. Here the classifier is loaded, and now there is an error in the, but this is just a warning. So now you see here you can see the camera of the robot and the detected signal with this procedure. For example, left arrow, the previous one was the stop, now it's turning, because this is the order that you calculate to following the track. Now it is following the track. On the top of left you can see the track that is detected. So here a right arrow, for example, and so on.